So let's start our lecture series on probability. So in this video, we are going to discuss some basic definitions. So to build up a base for the chapter probability. So in probability, what we do is we perform some random experiments. So then we talk about different type of events and sample spaces and many things. So let's start with the definition of random experiment. So what is a random experiment? So the random experiment is a activity. Basically, if I say that toss a coin, so tossing a coin will give you two different outcomes. Yeah, so we are tossing a coin and it is random. The outcome is random, that's why it is called random experiment. So like we can't predict that I am tossing coin and I will get tail or head, but I can't predict exactly that this will surely happen. Yeah, but we can say about possible things but not exact. So let's write the definition of random experiment. So random experiment, an activity which satisfies the following two conditions. First one is it has more than one number of possible outcomes. It has more than one possible outcomes. So here outcome means possibilities. Outcome means possibilities. Or we can say like if I toss a coin, then what is a possible outcome? So that outcomes means what I will get. I will get either head or tail. So second condition is it is not possible to predict the outcome in advance. So we can't predict the outcomes in advance in random experiments. So there are few examples. So first example is tossing a coin. So when we toss a coin, then there are two different possibilities, and we can't predict that outcome will be head or outcome will be 10. But we can say that there are different two possibilities for outcomes. We are not sure that I'm going to toss a coin and I'm surely get a head. Yeah, so that's why it is a random experiment. So let's say see second example. uh, Suppose I take a number 36 by 7. So this is not a random experiment. You know why? Because there is only one possibilities. This doesn't satisfies the first condition. Suppose there is experiment like we can say I have a box and I have written a number on a paper and kept in the box, and if I tell someone to card a paper from that box, so there is only one possibility that card will show that number or paper will show that number 36 by 7. So it doesn't satisfy the first condition, that's why it's not a random experiment. And let's see next example, rolling a die. So if I roll a die, then what are the possible outcomes? So you may think that possible outcomes are 1, 2, 3, 4, 5, 6. So that's true. That's correct. Yeah. So can you think of that? Can you predict? Can you predict the outcome? No, because it's randomly. Means we can't say that if I roll a die, I will get 6. What's your? Yes. Yeah. So that's why it is a random experiment. It is not a random experiment, and this one is random experiment. Yeah. So let's have a look on some examples on random experiment. So can you give me some other examples? Suppose if I toss a coin and roll a die, then what do you think? Is it a random experiment? Is it a random experiment? So tossing a coin will give me two possible outcomes, head and tail, and rolling a die will give me six possible outcomes, 1, 2, 3, 4, 5, 6. So if I toss a coin and roll a die together, I will get different types of combination, like head, then 1, head 2, head 3, head 4, head 5, head 6, and similarly we'll tell 1, tell 2, tell 3, tell 4, tell 5. Yeah. So even here I can't predict that I will get a particular outcome. Like if I say that if I toss a coin and roll a die, I will get head and 2. So it may possible that I will get, but it's not sure that I will get head as well as 2 on the die. So yeah, next we'll see some other definitions, like what is sample space. So the sample space is it is a set. Basically, it is a set that contains all the possible outcomes of a random experiment. Yeah. So we are performing a set. Suppose we are rolling a die, rolling a die, and the possible outcomes are 1, 2, 3, 4, 5, 6, and these are all only possible outcomes. So if I put these possible outcomes in a set, and then this set becomes our sample space. Yes. So let's write the definition of sample space. So definition is the set of all possible outcomes of an random experiment is known as the sample space of the experiment, and the sample space is denoted by that notation is capital S. Usually we denote sample space by capital S. So let's write some examples. As already we have seen that if I toss a coin, then my sample space S is head and tail. Second, if I roll a die, I have already written. Yeah. So yeah. What if I say that what will be the sample space if a random experiment consists of measuring the lifetime of a car, then the sample space. So what will be the sample space? So sample space S will be the lifetime of a car. So if someone buys a car, then what will be the lifetime of car? So it may possible that car will not start. So its life will maybe zero, and it may possible that it will run forever. Yeah. So sample space will be 0 to infinity, 0 close, infinity open. Next, we'll see about events. So what is an event? Event is basically nothing, that it's a subset of sample space. Like if I am rolling a die and I say that I want to discuss only about the possibilities of getting even number. So that possibilities of getting even number, I will say that the event of getting even number. Yeah. So what is the event? Event is any subset of sample space. S is called as an event. Yes. So let's see some examples. So in the above experiment, what we have seen, we have done, we have tossed a coin and we have rolled a die. So if I say in tossing a coin experiment, if we say capital E with the event of getting head is the event that a head appears on the flip of the coin. So, will it be a event? Yes, certainly it will be a event because while tossing a coin, the random experiment, the sample space is either head or tail. So, sample space will contain head or tail. So, therefore, this set which contains only head is the event for flipping the coin. Also, we had a experiment on rolling a die. So, in rolling a die experiment, so is it possible to say that if I write E equal to 135, 135, so is it an event? Yes, yes, it is an event of getting odd numbers. Yes. And next, can you think of an event for the experiment of lifetime of a car? So you think, right? Yes. Okay. So next we'll discuss some operations on events. So operations on events means what are the operation we can perform on two different sets. Yeah. So either we can take union or we can take intersection. So there are two different possible operations. One is union and second one is intersection. So suppose we have an sample space. We have a sample space S and random experiment E and F. And how will you define the union of two sets? So we write union of two sets as E union F, and intersection we write as E in this notation. This notation means intersection and this notation means union. And sometimes we write intersection as E into F. So what is union mean here? So union means event E union F occurs if either E or F occurs. So if I discuss about union, so it may possible that the outcome will lie in either E or in F. But in intersection case, the outcome will lie in both. So event E intersection F occurs if both E and F occurs. So let's take an example. If E be the event of getting tail and F be the event of getting head, then what will be E union F? So E union F will be simply head, tail, and what will be the E intersection F? So there is no any common element in E and H, so it will be just a null set. Example 2. If I take E to be 1, 3, 5 and F to be 1, 2, 3, then what will be the intersection and union? So union will be 1, 2, 3, 5 and intersection will be only 3. You can check it. Yes. So there is a remark. So the remark is, if intersection of two events is empty, if intersection of two events is empty, then E and F are mutually exclusive. Yes. So I will ask you some questions. Write some events which are mutually exclusive. Yes, and we'll stop here. In next video, we'll discuss about the exactly what is probability.